All right, next on our agenda is this idea of convergence. What is convergence? I'm glad you asked. Okay, so let me give you the formal definition. Okay, and we say the limit as n approaches infinity of an equals L, where L is a finite number, if, now here we're getting some language. So one of the things, what I'm about to say is something that, like, when you study a certain field, there are certain patterns of language that just get repeated over and over again. This is one of those for math, okay? So if you don't understand it, that's okay. We're going to walk through it, but this is a common language, okay? So it's like you go to anywhere and you ask about the definition of a limit, it's going to be exactly what I'm about to say, all right? So for all epsilon bigger than 0, there exists, let me not use that sign. There exists an n bigger than 0 such that n bigger than or equal to n implies a sub n minus L is less than epsilon. Okay, so let's draw a little picture of this thing to sort of see what that's saying. Okay, so let's say we're going here, 1, 2, dot, dot, dot. Let's say this is n minus 1. Let's say this is n. This is n plus 1. Okay, now let's put L. Let's put L here. Okay. Okay. That's as close as I'm going to get. Okay, so what's going on here? Okay, so I could have my sequence A1 might be here, A2 might be up here, A3 might be down here, whatever, A sub whatever. I could have crazy things going on, you know. But once I pass L, once I pass N, I'm putting like a little band. First, actually, I should have put my band around it first. That's N plus epsilon. Sorry, L plus epsilon. Here's L minus epsilon. And once I cross this line, I can't go outside of here. Okay. Nope, not allowed. Nope, not allowed. I'm pointing to like try to go farther up and down, but y'all don't see that. Okay. So if I want to make this band even smaller, I'm going to have to make my n even larger. Now, that doesn't mean that like a sub 2 couldn't be here. It could be. It doesn't have to be there. Okay? It's once you cross that line, you got to be close to this thing. Okay? All right, so that's the formal definition. Let's look at that again. For all epsilon bigger than 0, that means I can choose any epsilon I want. Okay, and I can do this. For all epsilon bigger than 0, I can pick some n Okay, if I make my epsilon smaller, generally I'm going to have to make my n bigger. Okay, such that if n is bigger than or equal to n, if I've gone past it, then my sequence is close to my limit. Okay? All right. Talked about convergence. Let's do something very similar, which is divergence to infinity. And there's also divergence to negative infinity, but let's just do one for now. Okay? So what's that? So, by the way, that thing there means all this. Okay? We're going to do the same thing for divergence to infinity. We're going to write the limit as n goes to infinity of a sub n equals infinity. Oops, we got stuck close to one of our a sub 3's there, but we'll deal with it. Okay. What does this mean? Almost the same thing. For all n bigger than 0, there exists an n bigger than or equal to 0 such that n bigger than or equal to n implies that a sub n is bigger than or equal to m. Okay, so it's the same idea actually. Okay, except for now, instead of being close to our limit, we're being just bigger. Okay. So let's say we pick an m. Say that's m. Okay. And we're going to do our, 1, 2, dot, 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 and minus 1, n, and plus 1. Okay, so once we cross this line, we have to be above in that region. Okay, doesn't mean we can't be. Our a sub 1 could be here, but it doesn't have to be. Could be. Not until we cross this line. Now we're stuck. Okay, and the idea is that we can do this for any number. So we could keep pushing this higher, and if we push this higher, we're going to push this out farther. Okay? All right. So those are the formal definitions of limits and divergence to infinity. Okay? All right. Let me keep on here. So let me just do one more thing on this slide. Okay? So if we have convergent series, sequences. I get the words mixed up sometimes, I shouldn't. But if we have convergent sequences, then algebra works. What I mean by that is that the limit as n goes to infinity, an plus or minus bn equals the limit of an plus or minus the limit of bn. Okay, we can add and subtract limits and get the add or subtract of this. We can add or subtract sequences and get the adding or subtracting of the limits. Okay, we can also multiply. So if I have two sequences, they both converge, I know the limit of each, then the limit of the product's going to be the product of the limits. And same thing with division, but with division there is a caveat. I love saying the word caveat. And what would you think that would be? If you said you have to avoid dividing by 0, you were correct. Okay, so algebra works, just you have to avoid dividing by 0, basically. Okay, all right, I will see you all in the next video. Or you all will see me in the next video, I should say.